Thanks everybody for joining this week. This week we're going to be covering containerization, specifically around Docker and Kubernetes and Cisco container platform. This is one of those topics that has been getting a lot of attention lately. I think a lot of DevOps folks are coming out of school after dealing with container environments. They want to run that in production, and a lot of us infrastructure teams, we're like, what does that mean? What are containers? Like, how do I build a network around this or compute infrastructure around this? So that's kind of what we want to tackle today is the very high level. What are we talking about here? What's the driving force behind this? What are the benefits to the developers and the business ultimately? And kind of how can we get there? So that's kind of the topic today. And of course, you know how I am. If we're talking about where we're going, we got to talk about where we came from, right? So a quick history lesson on app servers. If we go way back in time, this even kind of predates my time in IT. Everything was hardware servers, right? So we would throw some servers into the data center, pieces of iron. They'd have one operating system on it, and we put a bunch of applications on it. The big issue with that model early on was I got all these different applications. They all have different dependencies for libraries, operating system, and things like that, dev toolkits. So if I have a SQL server that needs server 08, I'm talking way out of date, but still, and then I have another SQL server I need to run, needs to run on, server 12, what do? I'm gonna need two servers to support those two different database environments, right? And you can see over time with all these different applications, all these different dependencies and requirements, the data centers got a little unruly. I mean, how many data centers have you been in, Lance, where it's like 40 racks, now we only have 3 of them full.
Yeah, when I first started in IT, one of the big things they were moving was from physical servers to doing more virtualization, but mostly because as you're talking, servers only had one purpose, like, oh no, that server's only doing this one because you didn't even want to start doing shared resources at some point on some of those servers. So I had just joined when my company was going through the process of moving those, and then so you start looking, you're like, there's so many empty racks that are in this data center.
Yeah, it's funny. There's still so many data centers like that.
Yep.
So yeah, and kind of to lend to your point, that's what brought on virtualization. So the idea was we can have one really, really powerful hardware server or multiple powerful hardware servers. We throw a VM hypervisor on it, usually VMware, although Microsoft has Hyper-V. We know all the players in that game. And then we can deploy different virtual machines. Every virtual machine has its own operating system, its own libraries, and typically only runs one, maybe 2 or 3 applications, right? Only a handful of applications that are usually tightly related. That works fine. There's a lot of additional overhead with that, right? I mean, if I need 300 VMs, that means I need 300 operating systems.
Yep.
And if I have all these different operating systems, and they all need to be patched at different intervals, it kind of becomes a lot of work. And that's why recently we've seen a big uptick in automation and orchestration within the virtualization environments, right? So things like Puppet and Chef and Ansible. That way we can apply patches to the 4 different versions of Windows OSs we have and the 8 different Linux distributions we have in the environment. So, this is where a lot of folks are today. But from a DevOps perspective, there's so much more we can do. And that brings us to, of course, containers. A good PowerPoint has to have good memes, right? So, of course, I had to throw one in. This kind of shows you, one of the big objectives of containerization is we can package up the applications, the dependencies, those libraries, put them into an image. That makes it easier to deploy across different platforms, So let's say on-premise with UCS or HyperFlex. We can also deploy these containers into public cloud, right? AWS or Azure, Google Cloud. And since it's containerized, all those dependencies are included, we have that portability to take it anywhere. Another real nice thing, and we'll talk about this a little more in depth as we go here, but since it's all containerized into images, that plays really well with DevOps. You know, I'm not a developer. Lance, are you a developer?
No, I am not.
Right. But
Not
you know,
even.
Git, you've heard of Git?
Yeah.
Right. So the concept of code maturity, right, and be able to push and pull images and do versioning and diffs and documentation around that. Containerization of images works really well with that. So developers just, they eat that up and they love it. It's a way to use that compute without the overhead of VMs. So containers don't each deploy their own operating system. They'll all live within user space. They're also very dynamic. So, you know, I got a couple images at the bottom here. I heard a comparison one time. Chad Peterson told me this, and it's always stuck with me, even though it's kind of weird. Virtual machines are like pets. They're like dogs, right? So on the left there's my puppy Cinder. He's wearing a birthday hat because he had his 1-year birthday party a couple weeks ago, which is weird to me to do for dogs, but we did it. So virtual machines are like pets. You get them one day, you give them a name, you patch them, you're going to keep them for a long time, right? Years. And then eventually just it's time to move on to the next one, right? You know, they get old and busted. You need the new version. You need a new operating system. You need the newest version of the application, all its new dependencies. So you just retire that virtual machine. You spin up a new one, right? Containers are more like cattle in that they're purpose-built. You're not going to name them because someday you're going to have to take them to slaughter. And they come and they go really fast, okay? You know, the life of a virtual machine may be years. The life of a container may be minutes, hours, days. It's probably going to be much more short-lived, much more dynamic. So it's a really cruel comparison, but it's always stuck with me.
That's
heard
actually
that
really good. I have never heard that, but that makes so much more sense to where with your VM, you're investing so much time and care into this to where when you go into containers, you're just spinning it up fast as you can, and then you just destroy it as soon as you're done. Like it is a purpose built rather than, you know, like a partnership of, all right, here's what we have. I have this application. I'm going to take care of it. We're going to do all these updates. Yeah, I've never heard that, but that's a great analogy.
Yeah, you know, another benefit is being able to do all of that spin up and spin down dynamically. And we'll dive into that a little bit deeper and start talking about microservices in a few slides. But we talked about what containers are. We've compared them to virtual machines. They're definitely not the same as virtual machines. Let's talk about what containers are not. So I mentioned microservices. Like I said, we'll dig into this deeper later. But containers themselves are not microservices. Containers are just a packaged image, and you can put any application and set of dependencies into that container, right? It can even be a legacy application. And if you do that, you'll get some advantages, right? Like portability, but you probably won't get the advantages of, you know, being able to do canary releases and things like that. You know, it's really an entirely new development model. Containers are not virtual machines. We just covered that. The really important thing to hit on there is, since they're just user space, if you need like custom kernels or anything like that, containers are not what you need. You're going to need to stick to VMs. And containers are not magic. So we'll talk about some of the ways they seem like magic to us nowadays, but,
Yeah.
but they definitely are not magic.
I definitely want to add on that point of just because if you ever try and move a application into trying more of a container platform does not make your code better. Like you would have to do some serious investment to almost rewrite that application to be driven more on container side rather than being hosted more on the traditional VM. That I think a lot of people sometimes think just switching it will make things a lot better and easier, but you're going to either, you know, the same problems will carry over because just moving it doesn't make it better.
Yeah, and even though we're not developers here, we'll talk about microservices and kind of how the dev teams really can leverage microservices in combination with containers to make a truly portable dynamic application. So containers, the images are like VM images, right? They're like snapshots, but with a better developer user experience. So, you know, we talked about Git earlier, being able to push and pull images, right, and do versioning and distribution. That plays really well on the dev side. They eat that up. Now, there's a lot of different flavors of containers out there, low-level containers. Docker is what we're going to talk about today. LXC, Linux containers, is another fairly popular one. Docker is awesome. They have a free version. You can go download it right now and start tinkering with it. It'll run on Mac, Linux, Windows, and there's also online labs and stuff you can jump into. I'll show you some of that a bit later too. So real quick, actually I'm going to pop out and jump into a terminal. So as you can see, of course, I'm a Mac guy. I've got Docker running up here. Docker Desktop is running. Like I said, you can go get this for free, installed on your machine right now, and be tinkering by lunchtime. So Docker runs around a image repository called Docker Hub. So this is internet-based, and I just did a search on Docker Hub for Ubuntu, right? I happen to know there's an image out here that's an Ubuntu release that we'll tinker with here in a bit. But, you know, this is an example of publicly available Docker images. Of course, you know, your app guys are probably going to have private repositories, right? They're probably not going to be putting their source code all over out there on the internet. But,
Yeah, they might.
you know, well, maybe. I mean, we've seen that before too, unfortunately. But there's a lot of good public projects out there you can go and tinker with. So let's run one of those Ubuntu images. So when I run this command here, it's actually going to spin up a container using that image. Boom, run an Ubuntu shell. Ubuntu 20.04. So let's come over here to another tab. And let's do the same thing. We've got two different containers running that. So here we can see all the containers that are running on my machine right now. One in my first tab, one in my second tab. You see their uptime, their status. It gives them pseudo-random generated names. Unruffled Archimedes. Sure, we'll go with that. But these are totally isolated from each other, right? Even though these are both running the same image, what we do in one doesn't affect what's happening in the other. So for example, right here, we'll go into container number one, do a touch hello, created a file in root, right? Just called hello, it's empty. Go over here to our second container, we look in root, a file's not there. These file systems are totally separate. What happens in one container doesn't affect what happens in the other. So, you know, much like old hardware servers, you know, if you stand up two servers next to each other and you don't connect them to the network, they can't talk to each other, right? Containers are exactly the same way. The only way they can talk to each other is through the network. So that gives you really good security and isolation from an app dev perspective. Shell on down. Come back over here. See, now we just have the one container up now. There you go. Just like that, we've got Ubuntu containers running on the machine. It's really that easy.
Yeah, and I think you had kind of talked about this in the very beginning, but once again, there were no licensing costs to spin that portion up just to be able to start doing a service if you wanted. That's the beauty with containers that so many people are seeing is the ability to do it quickly and cost effectively if you can actually do those services on either a Linux or whatever service you want to try and do that on. I mean, that was just a matter of moments. You could, and then containers, you just start compiling, and you'll probably go into it. You just start putting more into it, and you just spin them up, and then as soon as they serve their purpose, they're done. So I love that cow analogy so much now. That will forever stick with me.
Those were very short-lived cattle, obviously.
Yep.
Yeah, they're gone. They've already gone out to slaughter. Under 2 minutes. All right. So you get the basic idea of Docker and running containers. It's very simple. How are the DevOps teams actually leveraging this and making it useful? Let's talk about containers at scale. Okay, so you know, let's say we get our application built out, containerized. We got these images. We're going to need dozens, hundreds, maybe thousands of different containers to truly run our application, right? So, one option is we hire an intern and put him in front of a green screen and he works like 24/7 and just builds and breaks down Docker containers, right? That's one way we could do it.
Yeah.
It's probably not the most effective, but that's one way we could do it, right? Like we literally can run containers like that. And that works okay in a development environment, right? Like I just want to spin up a container and run the application and, do QA or test dev, that sort of thing. But it doesn't work really well in production. So we've been talking about microservices a bit. Let's talk about what that truly means. It truly means taking the application and breaking it apart into a bunch of smaller services. Microservices is the perfect name. So this is like a social networking example here, right? We got a separate login service, a separate photo upload service, like service. These would all run on their own image and their own sets of containers. And the big benefit to this is that when we need to go patch something in the login service, right, we don't have to touch the other containers and images. We can make changes to the code in that image and deploy just the changes to that image on the fly. That way, we're not impacting the rest of the environment. I've never been a developer, but even on the infrastructure side, we've all heard the horror stories of our dev teams going, oh, we really want to make this one small change to the application, but we're basically going to have to rewrite the entire application to do it. Right? I mean, we've all heard those stories before. That doesn't make good business sense, right? Hundreds of developer hours just to fix one little thing that should only be a few lines of code is bad. And with all the new agile development processes out there and whatnot, it just doesn't make sense. The other thing is, since we're splitting this out into different containers, for demand, we can spin up, the login service as needed. And I'll use a different example instead of this social networking example, but think of finance industry, right? A bank. So I didn't know this, but apparently Mother's Day is like the hottest day out of the year for wire transfers. So let's say I'm a bank developer and I have this banking app, I have a login service and, an account balance microservice and a wire transfer microservice container. And I know, okay, demand is going to be up for the wire transfer portion of the application this weekend. We'll spin up additional containers just for that part of the application to take that workload. And we can do all that dynamically once we start talking about orchestrators and whatnot. But it gives you that perspective of being able to spin up and spin down different parts of the application that need to be utilized that way.
Yeah. Another good one is like Domino's. When you go in and you hit that order button, you actually just spun up a container instance of your order, and it's logging all these application portions of your cart and all these things. And every time you click on it, it just adds on to where, and then when you close it, it quickly writes it to the database. You come back in, you hit it, you bring it back up, spins up another container, references the data, pulls it back up to update your shopping cart. To where it's just the dynamic aspect. I like the part you also mentioned for the automation, to where you can also set this where you if it is, let's take the Mother Day example for wire transfer, you don't have to have somebody there spinning and clicking buttons to try and spin these containers up. When you have this set up to do automation, it will be aware of, oh, hey, we're having issues, we're not response times are bad, or we're already at capacity. I'm going to spin even more up. And then you to handle that threshold, you start realizing that, oh, I already have too many. And then it starts bringing it back down. That is the true beauty of the whole aspect there.
I think WebEx is another great example, right?
Yep.
The whole WebEx environment was, I don't want to say rebuilt, but repackaged to take advantage of microservices containers a few years back. And that really saved our bacon during COVID because, you think of the old days, a given application server for WebEx probably hosted WebEx meetings, WebEx events, and WebEx Training Center, right?
Yep.
So if we start spinning up more iron, but we really only need to spin up more horsepower for WebEx meetings, then that's kind of a waste of compute resources. So being able to break that apart is huge. And also, it allows our dev teams to be more productive, right? Because I can have a dev team dedicated to the login service, or the wire transfer microservice. And those guys only need to be focused on what their image and their part of the software package is doing. And that's usually how it works in legacy apps too, but it's even easier once you containerize all of it. So we talked about automation and how important that is. You know, orchestrators are usually the piece of software we use to actually tie all of this together and start doing all these dynamic different parts and pieces. You know, when we start talking about spinning up dozens of a specific container image, we need a way to get to it, right? I mean, if this is all happening dynamically in the background, it's not like a VM. You know, we're not going to go out and give it an IP address and a DNS name and all that. We need to automate the network portion of that turnup. And that's part of what container orchestrators do for us. You know, they help with load balancing to all those different containers that are doing the same thing. And with load balancing, you got to do health checks, right? I need to make sure all my different containers are still up and responding. And if not, I need to take it out of the load, you know, just like we do with modern day VM load balancers today. So there's a lot of different orchestrators out there. One we're going to talk about today is Kubernetes. Docker has their own, Docker Swarm in the Enterprise Edition. Apache, Mesos, Rancher, I honestly have never touched those, don't know anything about them. Kubernetes is the hottest. I mean, that is truly the one everybody is talking about. And we have Google search result analytics to prove that if you're that curious. Yeah, let's dive into Kubernetes for a bit.
Yeah, if you see the okay, I knew you were coming up with another meme. I was just about to say the Dilbert one where he's like, hey, we need to update these containers. Well, what do you mean containers? Kubernetes. Just saying words doesn't mean things are going to happen. So,
I think the wildest thing about Kubernetes is probably the abbreviation for it. The first time I saw K8S, I had no idea what they were talking about. I had to go back and Google that. It definitely it makes sense now, but you know, it didn't at first.
Yeah.
So what is Kubernetes? Container orchestration. So keeping the containers up, watching health on them, scaling them out dynamically or manually, doing the load balancing and the networking, routing the traffic to them. You know, spinning up a container is one thing. Spinning up hundreds of them and actually leveraging that in a production application is a totally different thing. Kubernetes is not Docker, right? Kubernetes can work with plenty of different container technologies. Today, you know, anything we talk about will be Kubernetes plus Docker, just because that's the most popular setup there is. But it certainly doesn't have to be. So something to keep in mind. What all can it do? So first off, Kubernetes is 100% open. It's open source, modular. Since it's containerized, your applications don't have to know anything about the environment they're being hosted on. And that's important to me because there's always this knowledge gap between the developers and the infrastructure guys, right? I mean, I don't know anything about development. We said that 3 times today. I just need to know enough to get their environment up, right? Yep. And something they can use. They don't want to know anything about my environment either. I mean, trying to explain something to a developer is like hard, you know, and same with storage and other compute resources. They just know we're going to create code that needs to run, you know. So Kubernetes helps us abstract that compute and storage and networking piece from the actual DevOps side. Self-healing. So, you know, Kubernetes can actually watch the status of our container images and look to see if they're non-responsive, right? And then automatically kill them off or restart them. We can dynamically look for spikes in demand and then spin up additional instances of those microservices to accommodate that. Load balancing, you know, we're talking about spinning up dozens or hundreds of containers. The application doesn't know or care about that, right? It just cares about, I know that I need to go hit the photo service and pull this photo down. Where do I go? We need that level of abstraction so that the application can reach that other service and pull that information. Write once, run anywhere. That's been something we've hit on with containers in general, but Kubernetes is supported on-premise virtually on any x86 platform. AWS has their service called EKS. There's lots of acronyms. I won't try to rattle them all off, but Azure has their own Kubernetes service. But what's really nice is, you can avoid vendor lock-in with Kubernetes in general, right? So maybe I want to be on-prem today, but I want to be able to scale into the cloud later. That's an option with Kubernetes, right? We can forklift a Kubernetes cluster and move it to a different cloud provider or different on-prem data center, even if it's entirely different hardware. So it just helps peel apart the app from the infrastructure.
Now, something I'll add in here, I don't know if you're going to go into it a little bit later, is it's mentioned here on the rolling updates, the ability to do patching in a live instance and using the load balancing to be able to offer up two different portions of it and see, all right, we're going to make this tweak and see what user experience is like. And if it goes bad, you just remove it and all the other containers come on, or you could do like a share. If you find something's working better, you can bring it up, do like a half, see what the experiences are. We're going to slowly shift everything now to this new version of it. And so there's a lot more flexibility without impacting the environment to see, if this feature is going to work, what are people's thoughts, where we notice something wrong, go ahead and implement a change for all the new ones being spun up to have this corrected. So the ability to do more dynamic feature updates or something that's happening without having to do like a hard shut, update a VM, bring it back up, was pretty cool when we started learning, like doing deep dives into the Kubernetes. Like that's actually pretty powerful.
Yeah, that's a great point. A lot of legacy applications, when it's time for a release, what do? We schedule a maintenance window that's 2 or 3 or 4 hours long.
Nope.
We deploy the entire application, cross our fingers, wait to see if there's any bugs. It takes up an entire Sunday for a lot of our customers. That's not the way like Facebook and Google and Amazon work, right? They're agile. They're constantly pushing updates to their code. And that's a great point. That's exactly how they do it, right? When they want to patch something, let's say they have 100 containers running the login service at one time, right? And we want to make this one little tweak. And they'll push that to 10% of those containers so that 10% of the users start to see that effect. And then based on that, oh gosh, that 10% is airing out. Like there must be a bug. Let's peel it back and take it back to QA and figure out what's going on. Or, hey, it's working great. Let's go ahead and push that out to the rest of the environment. Those canary releases are huge. And they can, I hate to say zero downtime. We know that doesn't exist, but it takes at least standard maintenance to near zero downtime, right? We can just constantly push in releases. And ultimately for the business, we get the product in front of the end user quicker that way, right? We're not waiting for that maintenance window. We can just go push it today once the code's ready, and test it and hopefully, verified good before we push it out. But I got to get my jabs in at some point. So I asked in my email, I said that I thought Kubernetes was a Pokemon. And I have to admit, I know nothing about Pokemon. My wife was trying to train me last night. But I got to ask you, Lance, if Kubernetes was a Pokemon, what would its superpower be?
I'm going to say it's got to be like a physical attack would be my guess. It doesn't sound anything different. So I would go with like either crush, swift attack, some of that nature.
I like swift attack because, that kind of goes hand in hand with what we were saying about, automated rollout. Swift attack.
Nope.
Like agile development due to a swift attack, minus 10 HP or something. I don't know. I really don't know anything about Pokemon.
I can bring my kids and they really talk about it.
We can probably do a whole hour on that.
Yeah, exactly.
So there's a lot of moving parts and pieces, right? Even in a standard Kubernetes deployment, you're probably not going to run. Oh, lost my screen.
Did you go too far?
You're probably not going to run one Kubernetes cluster, right? So if you're setting up several Kubernetes clusters, it's kind of a lot of work. And there's more than just installing Docker and Kubernetes to get this up and going, right? Kubernetes is missing a lot of parts and pieces. For example, monitoring. Prometheus or Grafana are super common open source solutions to monitoring Kubernetes clusters. But you're going to have to install that and configure that all on its own. Logging, EFK stack seems to be the most popular open source solution, right? Elasticsearch, FluentD, and Kibana. That's 3 different applications you're going to have to spin up, right, to get that part of the stack going. And I'll be honest, I can't see anybody's faces out there, but a lot of those words I just said, you're probably looking at me with deadpan stares. Like, what are those things? I've never even heard of those. I've heard of 1 or 2. So kind of my point is there's a lot of moving parts, and a big ask from customers lately has been, okay, my developers, my DevOps guys, they want to get into this Kubernetes thing. My infrastructure guys don't know anything about it. We've done a lot of training, but we still don't feel comfortable with all the different parts and pieces. We want a turnkey solution, and that's what Cisco Container Platform aims to do. We automatically include monitoring and logging applications within CCP. CCP comes to you as an image. You spin it up. Traditionally we do it on Hyperflex. That way you get compute and storage. You spin it up. It automatically deploys Kubernetes, Docker. You can have multiple Kubernetes clusters within that. You can manage both on-premise Kubernetes clusters and off-premise public cloud. Today we support EKS on AWS, and then AKS is coming, but that's the Azure version, and then also the Google Cloud version is on the roadmap. So eventually we'll support all 3. Some other features we include multi-GPU support. So, we talk about standard workloads, nobody thinks about GPUs, but what if I want to start containerizing like AI ML workloads? I'm probably going to need to put some GPUs in place somewhere. Getting that to work with Kubernetes is a little painful. It usually requires pinning to, statically pinning containers to specific GPUs, and that doesn't scale well for obvious reasons, right? We want to decouple the development and the infrastructure, not pin them together. Within CCP, we can do multi-GPU support. So it'll automatically provision GPU drivers. You can use multiple GPUs across worker nodes. It's real nice. Persistent storage. That's always an issue with containerization anyway, and we have lots of solutions for it. But with Hyperflex, HX actually has drivers that will listen for persistent volume requests in Kubernetes, and then it can automatically spin up and present those Hyperflex storage volumes to Kubernetes. And that's all developer friendly.
Yep.
Like if a developer can stand up a PVC, which is like Kubernetes 101, he doesn't even know anything about Hyperflex to get that going.
Yeah, the one thing that's always going to stay the same is storage. And that's the reason why Amazon loves containers, because you're putting storage in their cloud that then are you going to pay when you offload it or bring it offsite? So, that's not just saying it's all the cloud providers. The thing that they get is, sure, you can spin these things up, but something's going to stay. There's going to be a persistent source of data that's going to have to go somewhere, and you can either, if you're on-prem, luckily you don't have to pay to try and move those off. But if you're in the cloud, how are you going to save it, and then how are you going to present it every time you need to do it? So storage is the one thing that's always going to be needed, and it's tough to solve for how you're going to handle it.
It's tough to do manually, right?
Yeah.
Especially if we're trying to stretch across multiple on-prem architectures and public cloud, because presenting storage in AWS is way different than doing it, on a Hyperflex cluster, right? So we want to make that as easy as possible for the app devs. AD off. I don't know what it is about open source projects. Like, I swear, these guys never think about centralized authentication, right? And developers never do either. But we need to be able to secure these platforms, just like we secure our VMware environments today. So with CCP, we can do role-based access control, and we can do AD authentication. So, you can give developers just as much access as they need, no more. You can get into the Kubernetes interface. It is 100% Kubernetes, so you're not vendor locked in. I really love to point that out, because, nobody likes being locked in, right? Just because I start with Cisco, who knows what my infrastructure looks like 2 or 3 years from now? you always have the potential opportunity to pick up that Kubernetes cluster and move it out of CCP. Yep. Really good networking integrations with ACI. Thinking about the security piece, that's another big thing too, right? Like, I want to be able to enforce security policy within my container environment, even though I'm multiple layers below my network, right? ACI and CCP can integrate so that you can actually apply those SGTs to that traffic and enforce the policies just as if they were VMs or iron servers.
Yeah, I've heard a couple of stories where, like, most of the time the developers don't really care about anything about IPs or the subnet. They just want something on and they want to talk, and they don't really care if it's on a secure subnet or anything. To where if you put ACI with it, you're able to have the same security you're expecting, or at least with the grouping. That way the person spinning these up doesn't have to have any concern for those. They know it just gets pulled into the file that they're using for their container, so that way it's oh man, at least I know no matter what he spins up, it's going to be safe. And they don't care about bugging you for any type of network information. They can just plug that into their services script, and then they're good to go.
Yeah, and I won't start a rant on that. We'll probably pick another day to talk about just ACI in general.
Yeah.
But how many times have developers or app owners came to us as infrastructure guys and said, just open up the firewall. Come on, man, just make it work. I don't know what ports I need. Just go make it work. Come on, open it all up.
Been there once or twice.
That gives you a little better visualization about what CCP looks like, all the different moving parts and pieces. Obviously, this shows an on-premise deployment on Hyperflex. But we spin up all the orchestration within a Kubernetes cluster. So, I should have put a meme on this page too, but yo dog, I heard you like Kubernetes, so we deployed Kubernetes in your Kubernetes. And now you can Kubernetes while you Kubernetes.
Just keep going, that's right.
But it obviously works really well, right? So we can actually run all that across the entire VM cluster. And then you can run multiple tenant clusters. So, that's super common that folks will want to do different Kubernetes clusters, maybe one for test dev, one for production. That way, you're totally separate. And you can still obviously move images between them, right, between the repositories. But that way you can do a lot of testing and you're not going to impact anything over on the prod side. Git cloning to prod is like a nightmare for developers. We don't want to do that. So we covered a lot of topics today. I know it's super high level. It still took us 40 minutes without, just to talk about the high level stuff. We can go on for days easily. The best way to learn about this is to go out there and get your hands dirty yourself. There's lots of good tutorials and videos, but I highly recommend, spin up Docker on your machine, or if you have a VM environment at home, use that to spin up a Kubernetes cluster. There have been a lot of adaptations of Kubernetes. Minikube is one that I run on my Mac that allows me to run Kubernetes even on just a MacBook. And there's lots of good web resources out there. So the first one we have here, dcloud and developer.cisco.com. We actually have a dcloud environment. It's got a CentOS machine and like 3 worker nodes and a Windows workstation. It runs CCP in it. It's got Docker and Kubernetes in it. And you can go play in that sandbox all you want, right? Or in addition to that, we have a learning track on developer.cisco.com just for containers. And that'll take you through setting up Docker on your own machine if you want to, or setting it up in that dcloud environment. And then, actually doing some pushes and pulls and playing with different container images and whatnot. Kubernetes.io, that's the Kubernetes website. They have fantastic tutorials that you can do right there in your browser. So if you want to go tinker and you don't want to install stuff on your machine, or the pesky sysadmins won't let you, either way, then you can go out there and do the tutorials right there in the browser. It's really simple stuff too. I mean, they literally they'll give you every command. So you don't have to be a Linux expert. You don't have to be a developer to go out there and start tinkering and get a feel for what all this is. Play with K8s.com. Another really good sandbox environment. It is, truly just a sandbox. There's no tutorials or anything on the site, but it's pretty robust. I mean, you can deploy a web application on it. The labs are only 4 hours long, so don't try deploying production or anything. But they give you a URL, and you can go deploy a web app and hit it from your PC at home. So it's a very robust sandbox. And then I know we only briefly talked about CCP here at the end. Definitely hit us up if you want more information. Like I said, there's been a ton of interest lately. We have bundles where we can bundle together CCP subscriptions with an HX cluster. And then you can have your dedicated Kubernetes cluster, right? And then you're ready to scale, to public cloud and beyond, or whatever you need to do. So Definitely hit us up. We can do trials on that, and we can definitely do an in-person demo if that's appealing to you.
Yeah, especially now that with Cisco Live was this week, and I don't know if everybody knows it, but DevNet is the developer.cisco.com. So I know if you're just used to hitting DevNet, that's the site to go to. But we've got a lot of stuff there at DevNet, and like Susie, we did a great job of kind of just showing where we're really seeing where we just need to have the ability to learn this if we need to ever come across it or want to know more. And so we've got a great spot with DevNet to try and learn a lot of this stuff and get a place to fill. And one of the ones I watched for Cisco Live was the ability to do just a lot of updating, like YAML files and stuff like that, to interact with teams better, or do plugin functions, and a lot of stuff on DevNet. It's point and click to go through the steps to learn. So that way you're not having to read a book and then apply it. It's visual. You see it and then you apply the physical learning aspect of clicking through it, and it seemed pretty powerful. So that's definitely some really good places to go and learn a little bit more if you're interested.
Yeah, and DevNet's a fantastic resource. I know a lot of folks are still a little bit allergic to the idea of getting into development, but even stuff like this, stuff that's very relevant to infrastructure teams, like setting up a Kubernetes cluster to basically hand over to the developers, right? DevNet can help you with resources for stuff like that too. So definitely go check it out. In fact, we ought to do a DevNet session.
That's true. We should try to set that up one of these days.
We can build up a WebEx Teams bot or something kind of fun like that.
That would be pretty cool. Well, I will add in here. Go ahead, Jay.
No, you go ahead, Lance.
I was going to say that our next one was scheduled for July 3rd, but we are off for that Friday, so we will not have anything. And so the next Multicast Friday is going to be the 17th of July, and the idea on that one is going to be how a day one operation, if you're starting fresh or even trying to do a refresh, on how Meraki can do so much inside your network. So we will go through the steps of starting day one. I need to turn on my routing, and then from there wireless, and then you slowly expand your business. So we'll start the aspect of the Jay and Lance LLC. We'll run that. We'll show you how you expand your network and how Meraki plays a role in that, just so you can see how Meraki has a spot somewhere in your network that you may have not been aware of before, and how it can solve problems for you.
Yeah, I think Meraki has morphed a lot, and we'll talk about it more on that session. But a lot of folks still think Meraki is just a wireless company, and that's so far from the truth now. And
that's so
there used to be a ton of
2008
feature parity. Right. There used to be a lot of feature differentiators on Catalyst versus Meraki, and that gap's really starting to close. So they're definitely worth reevaluating, and we'll talk about some of those differences and some of the recent developments for sure. But that'll be a good session to hit.
Yep.
Awesome. Well, with that, I hope everybody has a good Father's Day weekend. If you need anything, give us a shout, but we'll see you guys in a few weeks.
Yep. Thanks, everybody. Take care.